Okay, the next subject is air sealing. So this is another thermal boundary measure that we use to increase performance. When most people think about thermal performance in the building, they normally think about insulation first. And insulation is a measure to impede energy moving through the solid parts of the building, the wall, the floor, the roof. Another thing that really needs to be considered is energy that's escaping the building by going through cracks or holes. This is often between assemblies or possibly holes drilled through an assembly. And it's interesting, but we haven't really thought too much about that in the past as an industry. But it kind of makes sense that you would have energy. It's easier for energy to escape by going through a hole than by trying to go through something solid. So recently it's become part of our protocol, the way that we build houses, to start consider air sealing. So if you think of a building, any building as more or less being a six-sided box, the first thing that you have to do is you have to come up with a plan of how you're going to make sure that that thing is airtight. And the way that you do that, the first thing you're going to do is, this is sort of a section of a building. We take out the plans and you take out a red pen and you actually draw a line around the perimeter of the building that you want to be your thermal boundary. The reason you do this is because you have to consider how you're going to build these various areas to make it as easy as possible to air seal. If, for example, you wanted to air seal around all the rafter tails coming through, that's going to be pretty time consuming. But if you can figure out a way to construct the building so that you don't have to deal with all these penetrations. In other words, you might bolt on the rafter tails after you're done with your air sealing. It'll make it a lot less labor intense and a lot less expensive to do that. Once you've sort of come up with your strategy, the main thing you're going to do is you're going to start to air seal all the expanses of surface that are the boundary between inside and outside. And there's many ways to do that. We've sort of settled on using membranes to do that. So this would be an example of a membrane. This is actually what we're using on this house. And this has particular properties that are important when you're making a tighter construction. So this is designed to resist transfer of air and to properly deal with the transfer of moisture. So once you've done your first round of air sealing, you're going to want to do a test while the building is still open so you can make sure that you're close to whatever your target is. This building has been framed and the doors and windows have been installed, so we have a boundary on the outside and we can test to make sure that we're getting to the level of performance that we need to get to. In Passive House, you need to get to 0.6 air changes per hour. So that means whatever volume of air is in this building under test conditions, which is a situation where you very slightly pressurize the building to create a differential, only 0.6 of the total volume of air is leaking out of the building. By contrast, the code model is 7 air changes per hour. So you can see it's quite a bit less air movement that's required to get to the Passive House standard. As it happens, we've already done our preliminary test here. We did it a couple days ago, and we got to 0.33. So we're just about twice as tight as we need to be to hit the standard, and that's just on our first go round. So we're doing pretty good here.